This is the first video in a brand new series, AI by Subject. Instead of general study tips, each video in this series goes deep on one subject and the AI techniques that actually work for it. And we're starting with math because I think math is where the temptation to just get the answer from AI is strongest, and also where it hurts you the most if you do. Let's get into it. Everyone uses AI to check their math homework at this point. That's not really in question anymore. What's in question is how they're using it. Most students are using it to skip understanding entirely, paste the problem, copy the final number, move on to the next one. And that works great, right up until you're sitting in an exam room with no AI allowed, staring at a problem that looks almost exactly like the ones you did for homework, except now you actually have to do it yourself. Today I'm giving you 4 techniques that flip this completely. Ways to use AI to check your reasoning instead of replacing it, plus an honest look at where the actual line is on graded homework platforms, because that part matters too. Let's talk about the actual difference between how most students use AI for math and how you're going to use it after this video. Answer mode looks like this. You paste the problem into ChatGPT, it spits out a final number or a final expression, you copy it into your homework platform, and you move on. It feels efficient. It feels like you're done. But here's the thing. You didn't actually do any math. You did data entry. Understanding mode is completely different. In understanding mode, AI checks your reasoning after you've already attempted the problem. It shows you a second method to confirm your answer. It explains why a formula works instead of just telling you to apply it. You're still the one doing the actual math. AI is just there to catch mistakes, offer a different angle, and deepen what you actually understand. This is the mindset shift the entire rest of this video is built around. Everything from here forward assumes you're trying to get better at math, not just trying to get through tonight's problem set. First technique, the step-by-step prompt. Here's exactly what to type. Solve this step by step and explain why each step follows from the previous one, not just what the step is. Here's why the wording matters so much. If you just ask AI to solve this step by step, you'll usually get a numbered list of mechanical moves. Multiply this, subtract that, without any explanation of the logic connecting one step to the next. That's not actually more useful to you than just getting the final answer, because you still don't know why those particular moves were chosen. Adding that second half of the prompt, asking specifically for the why behind each step, forces the AI to expose its actual reasoning. Now you can compare that reasoning against your own intuition. Does it make sense why they factored at that specific point? Does it make sense why they chose substitution over integration by parts there? That comparison is where the real learning happens, not in watching numbers move around, but in checking whether the logic connecting them actually makes sense to you. Second technique, and this is probably the single most valuable one in this entire video, the check my work prompt. Here's the exact wording, here's my solution, don't solve it for me. Just tell me at which step, if any, my reasoning breaks down. Notice what's different here. You do the problem first, completely, on your own, before you ever open an AI tool. Then, and only then, you paste in your actual work and ask AI to find the error. Not to redo the problem, not to hand you a clean alternative solution, just to identify exactly where your logic went sideways, if it did at all. This is enormously more valuable than getting a fresh answer, because it's diagnostic. It tells you specifically what you're getting wrong. Was it a sign error in step 3? Or did you misapply the chain rule in step 5? Instead of just handing you a completed solution that teaches you nothing about your own specific mistake, you fix your actual reasoning instead of replacing it with someone else's. Third technique, the different method prompt. The wording, solve this same problem 2 completely different ways and show me how the answers agree. This one does 2 things at once. First, it's a sanity check. If 2 completely different methods land on the same answer, you can be a lot more confident that answer is actually correct, which matters a lot when you're studying alone without anyone to verify your work. Second, and honestly more importantly, seeing 2 different paths to the same destination builds something math classes rarely teach directly, real number sense. You start to see how, say, a geometric approach and an algebraic approach to the same problem actually connect underneath the surface. And practically speaking, this also gives you a backup method for exam day. If your first approach to a problem stalls halfway through under time pressure, having seen a second method means you're not stuck. You've got another way in. Fourth technique, The why prompt. This is the one I'd argue matters most for your actual long-term math ability, even though it might feel the least urgent in the moment. The wording: explain why this formula works, not just how to use it, like you're explaining it to someone seeing it for the first time. Here's the problem with just memorizing formulas. Memorization fails you the exact moment a problem looks slightly different from the examples you practiced. You plug numbers into the quadratic formula 100 times, but the second a problem asks you to derive it or apply it in a context you haven't seen before. Memorization alone leaves you stuck. Understanding why a formula works, where it actually comes from, what problem it's solving underneath the symbols, means you can adapt it. You're not just retrieving a memorized string of steps, you're reconstructing the logic on the fly, which works on problems you've genuinely never seen before. This is slower to build than memorization, but it's the difference between being good at practice problems and being good at math. One real problem, an optimization problem, the kind that shows up on basically every calculus quiz. Step 1. Attempt it. Before touching AI at all, I solved the problem myself, completely, start to finish, even in the parts where I'm not totally confident I've got it right. This step is non-negotiable. Everything after this depends on you actually having attempted the problem first. Step 2, check it. I paste my full attempt into AI and ask exactly where, if anywhere, my reasoning breaks down. Maybe I set up the constraint equation wrong. Maybe my derivative was fine, but I made an arithmetic slip near the end. Either way, I now know precisely what to fix. Step 3, see it differently. I ask for a second method. Maybe solving the same optimization problem using a slightly different substitution, or approaching the constraint from a different angle. This either confirms my answer, or reveals it was wrong in a way Step 2 hadn't caught. Step 4, understand it. I ask why the core technique, using a derivative to find a maximum or minimum, actually works, conceptually, not just mechanically. What is a derivative equaling 0 actually telling us about the shape of the function at that point? By the time I've gone through all 4 steps, I haven't just gotten an answer and I've solved the problem myself, verified it 2 different ways, and understood the underlying concept well enough to handle a problem I've never seen before. That's the entire goal. Now the honest part, because I think this genuinely matters and I don't want to skip past it. Most online homework platforms, the WebWork, MyMathLab, and similar systems a lot of schools use, can flag near identical solutions across submissions. And copying an AI-generated solution straight into a graded problem set is exactly the kind of thing that gets flagged, because AI-generated solutions to standard textbook problems tend to look extremely similar to each other across different students who use the same prompt. Here's the good news. The 4 techniques in this video don't have that problem at all, because you're the one actually doing the math in every single case. AI checks your work, shows you an alternate method, and explains concepts. But the actual solution you submit is yours, produced through your own problem solving, not copy-pasted from a chat window. If you're ever unsure what's specifically allowed for a given assignment or platform, just ask your professor or TA directly. Almost universally, they're completely fine with AI being used as a check on your own work. It's specifically using it as a shortcut to skip the work entirely that gets you into trouble. Let's bring it all together. 4 techniques. The step-by-step prompt, which forces AI to explain its reasoning instead of just its mechanics. The check my work prompt, which diagnoses your specific mistakes instead of replacing your solution. The different method prompt, which builds number sense and gives you a backup approach for exam day. And the why prompt, which builds understanding that survives problems you've never seen before. Try just one of these on your very next problem set and let me know in the comments which math topic you used it on. Next up in this series, AI for coding done the right way. How to use AI to pair program and debug without losing the actual learning that makes you a better programmer. If that sounds useful, go ahead and subscribe, and I'll see you in the next one.